4, that is Introduction to Business Intelligence. In today's session, we are going to learn about the OLAP, that is Online Analytical Processing. After understanding OLAP, we are going to learn about the characteristics of OLAP. And there are the different dimensionals of the OLAP: one-dimensional, two-dimensional, three-dimensional. And then we are going to learn about the advantages of an OLAP system. Then very important, in the last lecture we have seen the OLTP, and today we are going to learn about the OLAP, and at the end we are going to see the difference between OLTP and OLAP. So online analytical processing. OLAP means what? Online analytical processing. So OLAP differs from traditional databases in the way data is conceptualized and stored. Okay, so this OLAP is different from your traditional databases, and data is conceptualized and stored in different way. In OLAP, data is held in dimensional form rather than the relational form. This is one of the most important thing with respect to OLAP is whatever data held in OLAP, it is in the form of dimensional form rather than relational form. So data is present in the form of dimensional. OLAP lifeblood is multidimensional data. Okay, so main part of the OLAP is multidimensional data. OLAP tools are based on multidimensional data model. The multidimensional data model views data in the form of data cube. So whatever data you will view in the OLAP, it is in the form of data cube. So keep in mind, OLAP store the data in the form of cubes. Online analytical processing, that is OLAP, is a technology that is used to organize large business databases and support business intelligence. So this is the main object of the OLAP. It is used to recognize large business databases and it supports business intelligence. It supports business intelligence. Once you understand OLAP in detail, you will understand how it will support the business intelligence and how it is very much important in business intelligence to have a OLAP system. OLAP databases are divided into one or more cubes. So whatever data present in the OLAP, it gets divided into one or more cubes. The cubes are designed in such a way that creating and viewing reports become easy. So these cubes are designed in such a way that creating and viewing reports become easy. OLAP databases are divided into one or more cubes. OLAP databases are divided into one or more cubes, and each cube is organized and designed by cube administrator. Each cube is organized and designed by cube administrator to fit the way that you retrieve and analyze the data. To fit the way that you retrieve data, so that it is easier to create and use the pivot table report and pivot chart report that you need. We are going to learn what is this pivot table and pivot chart reports in detail in coming lectures. OLAP is a category of software that allows users to analyze information from multiple databases at the same time. So this OLAP software allows us to analyze information from multiple database systems at the same time. It is a technology that enables analysts to extract and view business data from different point of views. It enables analysts to extract and view business data. What is this mean? What is mean by extract and view business data? We will see in detail in coming lectures, so that you will get the detailed idea how this OLAP will help analysts to extract and view business data from different point of view. From different point of view. Analysts frequently need group, aggregate and join data. So analyst person, that is data analyst person, requires group, aggregate and join data. These operations in relational databases are resource intensive. With OLAP, data can be pre-calculated and pre-aggregated, making analysis faster. So in the OLAP, the data is pre-calculated as well pre-aggregated, so that it will be easy for faster analysis. It provides multidimensional view of data. It provides multidimensional view of data. It is used for analysis of data. Used for analysis of data. Data can be viewed from different perspectives. Data can be viewed from different perspective. You will understand this in better way in next lecture. What is meant by this different view from different perspective. And it is very much helpful to the manager to view the data in different perspective, so that manager will get exact idea what data is, and based on that manager can take the decision. And this OLAP views, multidimensional views, will help manager to retrieve the data, view the data in different forms, and based on this the manager can take the decisions. Determine why data appear the way it does. Again, it will inform the manager that why the data appear as it is present in the database. Next is drill down approach is used to further dig down deep into the data. We will learn it in detail in the coming lectures. So this is the diagrammatic representation of the OLAP. Data is present in multidimensional form. This is one dimensional, this is another dimension, and this is the third dimension. So now you can understand. So this one show how data is present. This is the cube which will represent the data, and different views of the cube will help manager to analyze the data. So in this, if you go for this direction, the measures are stored. That is unit sold, gross revenue, cost of goods sold, net revenue, average sale price. Whereas this product will be present in this dimension. Accessories, bikes, clothing, and component. And this is the time dimension. This is the time dimension. January, February, March, April, May, and so on. So data is present in this way in the OLAP. Suppose you want to know in the January 15 how many units sold of the accessories. So you need to retrieve this data. Similarly, if you want to know in the January 15 how many units of clothing sold, so you need to retrieve this data. Suppose you want to know in the January 15 what is the average sale of bikes. So in this case, this is the average sale price, and here it is the bikes, and in the January 15 is this, nothing but this one. If you want to retrieve the data of February 2015 of the bikes having the average sale price, then you have to retrieve this colored box. Similarly, if you want to retrieve in the May 2015, you want to know the average sale price of the clothing, then you need to retrieve this data, or this data represents by clothing average sale of the clothing in the month of May. So this is how your data is stored in the OLAP system, and this will help you to understand the further points in the unit. So this is the another example, OLAP. Let us consider data of supermarket store, all goods store. This is the name of the supermarket, all goods. So this is the data for the year 2001. This data is captured by OLTP system and is under the following column heading. So section, product category name, year, quarter, and sales. So actually these are the headers of the data. So you can imagine this is the table and these are the headers. First is section, next one is category name, next one is year, quarter, and next one is sales amount. We have total 32 records, that is rows. The section column can have one value from the main, woman, kid, and infant. So this section will hold among the values main, woman, kid, or infant. Similarly, product category name column can have either the values accessories or clothing. So this product will hold accessories or clothing. The year quarter column can have one value from the amongst quarter 1, quarter 2, quarter 3, and quarter 4. So this year quarter store values Q1, Q2, Q3, and Q4. And sales amount column record the sales figure for each section. That is product category name and year quarter. So it will store the total amount of the sales. So this is the one example that stores the all good store market data of year 2001. Now see, it will look like this. This is our section, this is our product category name, this is year quarter, and this is our sales amount. The section would store the main, woman, kid, and infant, whereas product category will store the accessories and already said clothing. So in this example, they have mentioned only the accessories, and this year quarter we store the quarter 1, 2, 3, and so on. Your quarter belongs to that particular purchase, and sales amount we store the total amount. So this is how your data is present in the all good store market of the year 2001. Now we are going to learn how this data is used in the OLAP. Before that, we are going to learn about the characteristics of an OLAP. So it is a multidimensional analysis. The previous example shows how you can analyze the data with the help of multidimensional. It supports complex queries. It will support the complex queries. It supports advanced databases. If simple databases are unable to store the data, this OLAP system will have advanced databases that will store that data and which is used by the OLAP system. Support large databases, access different data sources, access aggregate data and detailed data. It is easy to use and end user interface. Easy to use graphical interfaces, familiar interfaces with the previous data analysis tools, and the graphical view of the OLAP is user friendly. It follows the client server architecture. It provides the flexibility, can be used on different computers. More machines can be added. So these are the characteristics of the OLAP. Now we are going to learn about the one-dimensional data. Consider the table shown in the earlier slide. It displays all goods stores sales data by section, which is one-dimensional. Figure 3.4 shows data in two-dimensional, horizontal and vertical. In OLAP, it is considered to be one-dimensional, as we are looking at sales amount from one particular perspective, that is by section. So this will help. The section will, this section infant will have this sales amount, this kids section will have this amount, this men section will have this amount, and this woman section will have this amount. So this is called as one dimension. So given the name one dimensional data by section. Next is one dimensional data by product category. So this is the product category, accessories, and this is the total sale amount. This is the clothing, and this is the total sale amount. So the table name given one dimensional data by product category. Next is one dimensional data by year quarter. For this quarter Q1, this is the sale amount. For this quarter Q2, this is the sale amount. This is the quarter 3, this is the sale amount. This is for quarter 4, this is the sale amount. So this is how you can get data in one dimensional. Now we are going to learn about the next, that is two dimensional. So one dimensional data was easy. What if the requirement was to view company's data by calendar, quarter, and product category? Suppose now you want the data by calendar, quarters, and product category. So it comes under two dimensional. There are two dimensions for viewing the data. That's why it is come under two dimensional. Here, two dimensional data come into play. Two dimensional depiction of data allows one the liberty to think about dimensions as a kind of coordinated system. So this table gives you clear idea of two-dimensional data. In this table, two-dimensional year, quarter, and product category name have been combined. So year quarter Q1 will have these accessories and clothing and sales amount. Okay, this year, quarter, and product category are combined, and based on this, for this quarter Q1, for accessories this and total amount, total units of the accessories and total units of the clothing, and this is the sales amount. Similarly, for quarter 4, this is the accessories unit sold, clothing unit sold, and this is the total sales amount. So that's why this is the two-dimensional data by year, quarter, and product category name. Next is three-dimensional. What if the company analyst wishes to view the data, all of it along with the three dimension, that is year, quarter, product name, category name, and section, and all on the same table at the same time? They want all this data at the same time. So they figure for this the analyst needs a three-dimensional data view of the data. In the table, we can now look at the data by three dimensions. First is section, product category name, and year, quarter. The analysts want to look for the section which recorded maximum accessory sales in quarter 2. Then by giving a quick glance to table 3.48, he can conclude that it is the kids section. Now I am going to show you the table 3.8. So this is the 3.8 table. It's a three-dimensional data by section. So this is the product category name. Accessories, clothing. There are two categories of it. And then there are year quarter, Q1, Q2 to Q4. And then man, woman, kid and infant and total. So now if suppose you are going for quarter 1 or having the accessories, this is the men's unit sold, woman's unit sold, and this is the kids unit sold, infant unit sold, and this is the total unit sold. This is called as three-dimensional data, and this is required for analysis purpose at the management level. Now you can understand why important it is to have or to view this data in such a way. For clothing, quarter number 1, at quarter 1, this is a men's unit sold, woman's unit sold, and this is the kid, and this is the section, and this is the total unit sold. Now if you look at this figure, you can understand at the quarter 3, this number of kids units sold in the clothing section. So this is how this data will help you to analyze the business data, whatever you are having in the industry. So you need to have this view to look at this data. This is one example. Whenever you go for any industry, if your data is present and once it is in front of you, you need to think how this could be viewed. It could be viewed one-dimensional, two-dimensional, three-dimensional, and multi-dimensional, no problem. And you need to understand what this data indicates, and based on that you can predict what could this manager will take the decision. So can we go beyond three-dimensional? The answer is yes. If at all there is any constraint, it is because of the limits of your software. Only because of its limits of your software. But if the question is, should you go beyond the three-dimensional? We will say it is entirely on what data has been captured by your operational transaction system and what kind of queries you wish to OLAP system to respond. It depends on the kind of data present in the OLAP and which query you are going to fetch on this OLAP system. Now that we understand multidimensional data, it is time to look at the functionalities and characteristics of OLAP system. OLAP systems are characterized by low volume of transactions that involve very complex queries. Some typical applications of OLAP are budgeting. It is used in the budgeting, sales forecasting, sales reporting, and business process management. So this OLAP is used in various sectors in the industry, and as we have from different branches, it will help all the students to view the data in the OLAP form, and based on this, it is one kind of skill you will acquire that is needed by the industry to view the data. If suppose you are selected and you go to the manager post, this OLAP system, OLTP and database system will help you to understand what is going in that particular industry. With the help of data, you can understand it. You need to have this skill to look at the data. So I am going forward. Then this is the set of queries related to example. The queries could be answered like, what will be the future sales trends of accessory in the kids section? So such kind of queries can be handled by this OLAP system, and based on this data and based on this requirement of the query, you can understand what will be the future sales trend for accessories in the kids section. So similarly, given the customer buying pattern, will it be profitable to launch product XYZ in the kids section? You can answer this easily with the help of when you have a data in your hand. So OLAP gives you very much empowerment to take the decision based on the real-time data. What impact will a 5% increase in the price of the product have on the customers? If you increase the price by 5%, what will be the impact? Based on the previous trends, you can understand what will be the impact. So such kind of questions will be solved with the help of OLAP. Now understand the of OLAP. It is a multidimensional data representation. Till now we have seen only the one dimensional, that is rows and columns, but OLAP system views data in multidimensional form. There is consistency of information in the OLAP because data is collected from the OLTP system at various points, from the various points. This OLAP system allows you what if analysis. As this OLTP doesn't allow, but this OLAP system gives you what if analysis. What particular happen, then what will be happen. So it allows what if analysis. It provides a single platform for all information and business needs. It will help you for planning, budgeting, forecasting, reporting, and analysis. It will be fast and interactive, adapt exploration. This OLAP system is fast as well as interactive. Now we are going to learn about the difference between OLAP and OLTP. In the yesterday's session we have seen OLTP, in today's session we have seen OLAP. Now see the difference between both of them. So OLTP nothing but online transaction processing, whereas nothing but the online analytical processing. So main focus of OLTP is what? Data in. What is the main focus of OLAP is data out. What will be the output of, or what is the data out you will get from this OLAP system? What is the source of data? Operational transactional data. What is the source of OLAP data? Data is extracted from various operational data sources, transformed and loaded into the data warehouse. What is the purpose of data in OLTP? Manage basic business tasks. Purpose of data in OLTP is manage the business basic task. But what is the purpose of data in OLAP? Assist in planning, budgeting, forecasting, and decision making. This is the main purpose of data in OLAP. What the data contains in OLTP? Current data, far too detailed, not suitable for decision making. What this data will consist in the OLAP? It consists the historical data. It is kept in the historical data is kept in OLAP. Has support for summarization and aggregation. It stores and manages data at various levels of granularity, thereby suitable for decision making. Insert and updates. Very frequent updates and inserts happen in the OLTP, whereas periodic updates to refresh the data warehouse is done in the OLAP. Next is queries. Simple queries often returning fewer records in the OLTP, whereas in OLAP, often complex queries involving aggregations. Processing speed, usually return fast, whereas in OLAP, queries usually take long time to execute and return. There is huge amount of data, very complex queries, it requires some amount of time to get it execute and return back the result. What is the OLTP access? Field level access, whereas in OLAP, typically aggregated access to data for business interest. You will get the aggregated access to the data for the business interest. Next is in OLTP, database design is typically normalized tables. OLTP system adopts ER, entity relationship model. You are very much familiar with this entity relationship now. Now you can understand what is meant by entity relationship. So it is adopted by OLTP. Whereas typically denormalized tables uses star or snowflake schema in the OLAP. In coming lectures, we are going to learn star or snowflake schemas. So what are the operations in the OLTP? Read and write. Whereas in OLAP, mostly read operation. Data is retrieved for taking the decisions. Next is backup and recovery. Regular backups of operational data are mandatory. It requires concurrency control, locking, and recovery mechanisms, that is logging. Whereas in OLAP, instead of regular backups, data warehouse is refreshed periodically using the data from operational data sources. In the OLTP, there are many joins, whereas in OLAP, there are few joins. Data, derived data and aggregates, it will happen in the rear in the OLTP, whereas it is common in the OLAP. Few sample queries in the OLTP: search and locate student, print student score, filter students above 90% mark. Whereas sample queries in OLAP is: which course have productivity impact on the job? How much training is needed on future technologies for non-linear growth in the business intelligence? Why consider investing in DSS experience job, experience lab? So such kind of queries will be used in OLAP, and these simple queries are used in OLTP. So again, this is the difference between OLAP and OLTP. So this OLAP will shows historical data, whereas this OLTP stores the day-to-day processing. OLAP systems are used by knowledge workers such as executives, manager, and analyst, whereas OLTP systems are used by clerk, database administrator, or database professionals. It is useful in analyzing the business, whereas useful in running the business. It focuses on information output, information out. It focuses on data in. It is based on star schema, snowflake schema, and flex constellation schema. Whereas OLTP is based on entity relationship model. It provides summarized and consolidated data. It provides primitive and highly detailed data. It provides summarized multidimensional view of data, whereas this OLTP provides detailed and flat relational view of data. Number of users is in hundreds, whereas number of users is in thousands in case of OLTP. Number of records accessed in millions in OLAP, whereas number of records accessed it is in terms of tens. Data size is from 100 GB to 1 TB. Database size is from 100 MB to 1 GB. And this OLAP is highly flexible, and this OLTP provides high performance. So this is the difference between OLAP and OLTP. Now you can understand what is OLAP and what is the purpose of OLAP, and what is OLTP and what is the purpose